Hello everyone, welcome to Kinematics of Machines tutorials, and in this video lecture that I am going to explain about condition for kinematic chain and as well as Grublers criteria. Okay, so first we try to look at the condition for kinematic chain. So what is the condition we can consider? Means here we can consider two conditions to confirm whether the given chain is kinematic chain or not. Okay, these two conditions in the form of two formulas, basic formulas, which can be used for confirming whether the given chain is kinematic chain or not. So what are those two formulas we can consider? So let us look the two formulas. That is n is equal to 2p minus 4 and also one more formula, j is equal to 3 by 2 into n minus 2. These are the basic two formulas we can use to confirm whether it is a kinematic chain or not. So when there is an equality condition between these two values, that is on left hand side and right hand side, based upon that we can consider kinematic chain, whether it is a kinematic chain or not. So in these two formulas again, if you want to know what is npj means, n is number of links as usual, and p means number of pairs, and j is number of joints, and again here n means number of links. So by knowing number of links, number of pairs and number of joints, we can confirm or we can check, we can verify whether the given chain is a kinematic chain or not. So kinematic chain means already we have discussed whenever there is a constrained relative motion between each and every part of a chain, then only that chain can be considered as a kinematic chain. So to confirm that only, these are the two basic formulas we can use. So other than equality condition, if we get less than or greater than, so what we can consider, what is the name we can give to the chain, or what type of the what type of the condition we'll get from the chain. Okay, that we see now. So in the form of tabular column I am going to show you. So first condition is I am considering if the left hand side value is greater than the right hand side. From these two formulas, if we are getting left hand side is greater than right hand side, okay, whatever the formula we use, same values we get for a given particular chain. So in that condition, for a given chain, if the left hand side value is greater than right hand side, so what is the name we can give to the chain? Means here it is a locked chain. Okay, so when the LHS is greater than RHS, that chain is called as locked chain, and this type of chain is used for rigid frames or structures like bridges. Okay, for rigid frames and structures we can use the chain as it is a locked chain. That means there will be no relative motion between each and every part of the chain when this condition is satisfied. Okay, and now we consider the next condition. If we get left hand side value is equal to right hand side value, so in this condition it is satisfying the condition. Okay, so when this condition is satisfied, then the chain is called as your constrained kinematic chain. Okay, when there is an equality condition in between LHS and RHS value, then the chain given can be considered as a constrained kinematic chain. That means each and every link of a chain is going to have a particular directional motion, means a constrained motion between them. Okay, next we go for LHS is less than RHS. So when the left hand side value is less than right hand side value, in this condition what we can call the chain means here the chain is unconstrained chain. That means there will be no particular directional motion to each and every link of a mechanism. It means no relative motion between the two links. That means in a pair of elements. So irrespective of the when we change the direction of the force, the link also moves in a particular different direction other than in a definite direction. Okay, so when this condition is satisfied, we can call the chain as a unconstrained chain. Okay, try to remember these three conditions. Based upon that we can decide whether it is a locked chain, constrained kinematic chain, or unconstrained chain. I hope you understood. And next slide I am going to give some examples for each and every condition, that is LHS is greater than RHS, LHS is equal to RHS, and LHS is less than RHS. Okay, so first condition, we know that LHS is greater than RHS. When this condition is obtained, when we can face this kind of the condition, means here a simple example we can consider, that is as three links are connected in a shape of rectangle, and when we take this kind of the chain, it is not kinematic chain, that we need to prove. But actually the condition is LHS is greater than RHS, automatically it is not a kinematic chain. But whether it is a locked chain or not, we check it by using the any one of the two formulas. Okay, so three links, first we try to write number of links, that is n is equal to 3 links, and the number of joints is equal to also 3 joints, and the number of pairs is also 3. Okay, so now we use the formula n is equal to 2p minus 4. In this, in place of n we can write 3 is equal to 2 into 3 minus 4, and 3 is equal to 2 into 3 6 minus 4, then it will give you 3 is equal to 2. So it is not equality condition, 3 is not equal to 2, so which leads to 3 is greater than 2. So it means that left hand side value is greater than right hand side. So when we face this kind of condition, so the chain can be called as here locked chain. So when you use this formula also, the same condition will be obtained, that is left hand side is greater than right hand side. So ultimately this chain is called as locked chain. So this triangular form of arrangement of the links will give you locked chain condition. Okay, similarly we go for the next condition, that is LHS is equal to RHS. So for this I would like to take a 4-bar chain. Okay, this is the 4-bar chain, 4 links are connected together. In this, if you write number of links, that is n is equal to 4, then if you write the number of joints, that number of joints is equal to 4, and similarly number of pairs is equal to also 4. Again we try to use the formula n is equal to 2p minus 4, so n is 4, and that is equal to, we can write it as 2 into 4 minus 4 we can write, and then 4 is equal to, we can write it as 2 into 4, it becomes 8, so 8 minus 4, 8 minus 4 will get, so 8 minus 4 means we can write it as 4 4 is equal to 4, so both the values are equal, that is the left hand side value is equal to right hand side, so it becomes a kinematic chain. So when this condition is satisfied, we can consider the chain as a constrained kinematic chain. Got it? Next we go for LHS is less than RHS condition. So for this we try to take one more example, that is 5 links are connected together in this particular format, and in this number of links becomes equal to 5, and number of joints is equal to 5 only, number of joints if you count 1 2 3 4 5, so number of joints is equal to also 5, and number of pairs also becomes equal to 5. Okay, next we try to consider the same formula, n is equal to 2p minus 4, and then n is equal to means it will give you 5 is equal to that is 2 into 5, 2 into 5, 5 is equal to 2 into 5 minus 2 into 5 minus, and it will give you 4, 2 into 5 minus 4, and then finally we can write the values in the next step as 5 is equal to 2 into 5, it becomes a 10, 2 into 5 becomes 10. Oh god, sorry guys, it is responding slowly. Come on, 2 into 5, it is 10, make it 10, 10 minus 4, 10 minus 4, so we wait for that until we get the 4, then 10 minus 4, all we know that it is of 6, then finally what we can consider. So 5 is less than 6, so that is left hand side is less than right hand side. Left hand side is less than right hand side. So when this condition is obtained, we can call that the given chain is unconstrained chain. The given chain is unconstrained chain. So this is the 5 links format when it is given in a pentagonal shape or something polygon shape. So in this condition, when the links are connected, then we want to get the particular kinematic chain. Okay, sorry, it's giving a wrong value. Actually it should be 5 less than 6, not 4 less than 6, 5 less than 6. So try to make a correction here. So finally this link can be, this chain can be called as an unconstrained chain. Okay, we go to the next slide now. So next slide is about Grublers criteria. So this is the criteria which is given by the Grublers. So when we can consider this Grublers criteria means here, this criteria is basically obtained from Kurzweil criteria. And when this Grublers criteria is considered means when the higher pairs is 0, when there are no higher pairs in a particular mechanism, okay, that mechanism can be considered under Grublers criteria. So that means basically the Kurzweil criteria is used for finding the degrees of freedom, and that can be applied to normal lower pairs, which is a combination of higher pairs also. But here the Grublers criteria we need to apply only to the plane mechanism which are having only lower pairs. Okay, so which is also used for finding the degrees of freedom. And in this criteria especially, the degrees of freedom is assumed to be equal to 1. Why? Because when we use all lower pairs, we get the degrees of freedom as a 1. So this is applied to plane mechanisms and the degrees of freedom becomes equal to 1 only. So the degrees of freedom formula we know that 3 into n minus 1 minus 2j minus h. So based on Grublers criteria, we need to assume the h value should be as a 0. Then degrees of freedom becomes equal to 3n minus 1 minus 2j. And at the same time in this criteria we get the degrees of freedom for a plane mechanism as 1. So when this degrees of freedom becomes equal to 1, then the equation can be modified like this. 1 is equal to 3 into n minus 1 minus 2j, and that is equal to, when you take 3 inside, 3n minus 3 minus 2j. Okay, then if you take 1 on right side, then 0 is equal to 3n minus 3 minus 2j minus 1. 3n minus 3 minus 2j minus 1. Come on buddy, come on. Okay, so when the 2 minus 3 minus 1 we add it, then it becomes minus 4. Finally we can write the equation as 3n minus 2j minus 4 is equal to 0. 3n minus 2j minus 4 is equal to 0. So this is the modified form of the Grublers criteria equation. So when a particular planar mechanism is given, and if it is given as planar mechanism and it comes under Grublers criteria, if it is mentioned as it comes under Grublers criteria, and the number of joints are given and the number of links are not given, means we can find out the number of links with the help of this formula. So this Grublers criteria is only considered for plane mechanisms, and that too they should have degrees of freedom as 1. Okay, that is the importance of Grublers criteria. So I hope you understood, and sorry about that my system slow running. This PowerPoint is taking some time to respond to my input, and sorry for that. And regarding my explanation, if you still have any doubts, please feel free to give a comment to my video. And once again, Thanks for watching my video, and don't forget to subscribe to my channel. Thanks for watching my video. Thank you all.